The following 14 projects will teach how the 7-segment display can show different letters of the alphabet, depending on where the double snap wires are connected. The first letter you are going to see is a capital F. Now I am going to show you the letter H. Now the letter P. The letter S, which will basically be like the number 5. It's the same as the number 5. A capital U. The letter C, capital C. And the letter E, capital E. And finally, I can just have the decimal illuminated by making the following connection and then removing all others. Now I am going to move over to the lowercase letters. And there are 6 possible lowercase letters this display can show. I'm going to make the following connections for the lowercase c. Actually, the first was going to be a B, but I'll show you the C. You have a B for a D. Just move that 2-snap wire over there. Now, the letter E is a bit more complicated. Might be hard to see, but that's a lowercase e. The letter H. And finally, the lowercase o. Again, there are special displays that have more segments so that they can display all uppercase and lowercase letters of the alphabet in addition to numbers. This is a space war alarm that uses the Q3 diode, or SCR. Simply disconnect the jumper wire, and you hear a space war sound on the speaker. Reconnect the jumper wire and the sound stops. Now, with this particular circuit, the tone is always the same. It's the same every time you disconnect and reconnect the jumper wire. I replaced the R3 resistor with the photoresistor and removed the jumper wire. Now when there's enough light on the photoresistor, the space war sound starts. And again, the sound is the same always. This project is similar to 377, except now I'm using the alarm integrated circuit. When I remove the jumper wire, you hear an alarm. Now for some reason the alarm is skipping a lot, but nonetheless this circuit shows how the Q3 diode helps to power the alarm. Reconnect the jumper wire and the alarm stops. Like Project 370A, I'm using the photoresistor, but now you'll hear an alarm when there's enough light on it. Cover the photoresistor and the sound stops. This is a delay lamp. I'm going to turn on the slide switch and then hold down the press switch. After a few seconds, the lamp comes on. To turn the lamp off, switch off the slide switch. Now to turn the lamp on again, turn on the slide switch and hold down the press switch. Holding down the press switch charges up the capacitor, and when there's enough power in it, it will flow through, it will power the NPN transistor and then the Q3 diode, and that will turn on the lamp. This is a delay fan. I replaced the lamp with the motor and fan and moved the lamp down here. When I turn on the slide switch, nothing happens. Push and hold down the press switch for a few seconds and the motor and fan will spin. The circuit works the same way as it did with the lamp, but the lamp still illuminates in this one. To turn off the fan, turn off the slide switch. I'll turn it on one more time. And there you go. For the variant of the delay fan, I replaced the C4 capacitor with the C5 one. Now let's see how long it takes for the fan to turn on after I hold down the press switch. It takes significantly longer for it to come on compared to the C4 to when I was using the C4 capacitor. The greater the capacitance, the longer the delay for the fan or whatever to turn on. This is a recorder that has LEDs as indicators. After you build the circuit, both the red and green LEDs will be on. Now when I turn on the slide switch to record, the green LED will turn off and you will hear a beep to indicate that you can start recording. And then after a short period of time, you'll hear two beeps indicating that the recording session is over. Here I go. Are you excited for the holidays? I am. I don't think it recorded my entire message, but the green LED came back on. I'm going to turn off this slide switch and push the press switch. And then you'll actually hear a Christmas carol following my recording. It's not very loud though. By the way, the lamp is extremely dim and it's really used as a resistor to limit current. This is a recorder that uses the voltage meter, which will measure the current through the microphone. I am going to talk into the microphone at normal volume first. Here we go. Do you like to visit the zoo and see all the animals? And as you could see, the meter deflected quite a bit to the right because current was flowing through the microphone when the recording session is happening. When I play back the recording, sorry, it's muffled, but the meter doesn't deflect because this part of the circuit is still not energized. Now I am going to blow into the microphone next time. Watch the meter now. This time the meter deflects considerably to the right because me blowing into the microphone creates more powerful air vibrations. And the louder you talk, the more the meter will deflect to the right. I am going to play back my blowing. And there you have it. This is an alarm light. It will use a visual signal instead of an audible one. I have the lamp, and when I disconnect the jumper wire, the lamp comes on. However, unlike other alarm circuits, reconnecting the jumper wire will not turn the alarm, or the light in this case, off. Instead, you have to turn off the slide switch and turn it back on again to reset the circuit, to reset the alarm. Because with the Q3 diode, the circuit remembers if there was a break in the connection. This is another alarm light, except this one uses the Q2 transistor to work. However, the principle is the same. When I turn on the slide switch, nothing happens. Then when I remove the jumper wire, the lamp will come on. You could pretend that you have a longer wire running across a doorway, and then if an intruder removes or cuts the wire, the lamp will come on. And it will stay on even after you reconnect the jumper wire. So to reset the circuit, you have to turn the slide switch off and back on again. And you can do it again. Just to let you know, the adjustable resistor in this circuit serves as a fixed value, and moving its lever will have no effect. This is the night police car. When I turn on the slide switch and cover the photoresistor, you hear a police car siren. Now, for the first variant, a night machine gun, I place a 2-snap wire between these two locations, and now you hear what sounds like a machine gun. For the night fire engine, I move the 2-snap wire over here. Now it sounds like a fire truck. Finally, when I move the 2-snap wire over to these 2 points, the speaker makes ambulance sounds. And there you go. The following 4 projects have the opposite principle of the previous 4. First will be the daytime light police car. This time, when light is on the photoresistor, the alarm sounds. But when I block the photoresistor, it stops. And of course, I can use this 2-snap wire to vary the sound. I didn't do the variants in order, but they're very simple. This is the flashing number 8. The alarm integrated circuit controls the flashing of the 7-segment display. Some segments in the display may seem brighter than others. And I'm sorry that it's hard to see. It's very bright outside, but now hopefully you can see more clearly. Now I added the speaker, so although not all the segments light up, only one of them does right now, by means of the large amount of current that the speaker is using, you hear a machine gun sound. This circuit combines traditional music with Space War sounds. When I turn on the slide switch and there's enough light on the photoresistor, you will hear Space War sounds. And when I wave my hand over the photoresistor, the sound effect changes. Now when I push the press switch, you will hear a pre-recorded song from the recording integrated circuit. Covering the photoresistor will stop the Space War sound, but the song will continue to play. To change the song, hit the press switch twice. And you hear some beautiful Christmas songs. Now, if I wanted to, I could replace the lamp with the R1 resistor to make the circuit quieter. But there you have it. This is an electronic noisemaker. When you turn on the slide switch, you hear a high frequency tone from the speaker. You can change the frequency of the sound by pushing and holding the press switch and moving the lever on the adjustable resistor. On some settings, you won't hear anything. You can lower the frequency of the tone by replacing the C2 capacitor with the C3 one and pushing the press switch, which includes the capacitor. For electronic noisemaker 2, I replaced the R4 resistor with the R5 one. This also changes the tone's frequency. I can also still replace the C2 capacitor with the C3 one. Now, the frequency is even lower with the R5 resistor than with the R4 one. This circuit is designed to make sounds like those of a bumblebee. Hold down the press switch, and you hear tones like those of such an insect. Do they sound like a bee to you? You can also change the capacitor to make the circuit sound different. With the C3 capacitor, you just hear like some fast clicking sounds. Doesn't sound anything like a bee to me. I removed the speaker and inserted the whistle chip here. And the sound effect is much different than it was in the previous project. Does it sound like a bumblebee to you? Replace the capacitors, change the capacitors to make the circuit sound different. What does that sound remind you of? I replaced the C4 capacitor with the C3 one, and for this variant you can either use the circuit from Project 401 or the circuit from Project 402. I'm using the first one, and listen to how the circuit sounds now. I'm going to change the C3 capacitor to the C5 one to see if there's an even greater difference in sound. And there you have it.